in progress.
Good afternoon. Can you hear me? Hello?
Yeah, we can hear you.
Okay. So we finished the second exam. You can see your grade, right? Which is the highest grade is 96. Let me see. Average is 78. So if you cannot see your grade or if you have any question about your exam, you can email me, okay? We can discuss, we find some time to discuss that. Can you see your grade? I just want to double check on my course. Yes? Yes, okay. Okay, so that's about the second exam. And today we're gonna start new chapter, which is chapter 12. That's about the option pricing. So we're gonna have two chapters on option pricing. For option pricing, we need a model. So first we're gonna talk about the binomial model, and then we're gonna talk about the Black-Scholes Merton model. So that's chapter 13. So this week we're going to talk about the binomial model to determine the option pricing. And then next week we're going to talk about chapter 13. I just tell you the our plan for the remaining week. And after we finish the chapter 13, and we have a week, which is you work on your case project. And the last week, which is the week of excuse me. I think the week of 26, we have two classes for presentation. Okay, presentation. And the week following, which is the April 4th, we're gonna have final exam. Okay. So our exam will be April 4th from 11:30 to 2:30. Okay, that's the schedule from the school. So we have 4 weeks. Okay, we have 4 weeks. Any question? April 1. Oh, sorry, May 4th. The final exam is May 4th. Sorry. Yes. Not April. Maybe I said wrong, but it's May 4th. Okay. So today we're gonna start a new chapter, which is the chapter 12. Can you see my shared screen? Yes. Anyway,
Professor.
yeah. Yeah.
Yes, we can see it.
Okay, great. Thanks. So this chapter talk about the binomial tree to determine the option price, call price, put price. You might learn from other class, but in our class, we're gonna use like 2 different approach to demonstrate they are the same. So this approach you might not learn from other class, so you need to learn from this class. Okay, so this we're gonna talk about just one step. You might learn the multiple step, 2 steps, 3 steps, but 1 step is the basic. So as long as you know one step, you're gonna be able to do multiple steps. Okay, so 1 step binomial model, and we're gonna have 2 approach, which is the no arbitrage argument. That's the first like assumption. You can use this assumption to determine option price, or you can use risk neutral valuation. So this is like 2 different assumptions and 2 different approach. So you can use them and to separate to do your pricing, and you should get the same answer. Okay, so that's the main idea about this chapter. Okay, so first, 1 step binomial model. In contrast to the Black-Scholes and other complex option pricing models that require solution to stochastic differential equations, the binomial option pricing model, which is talk about 2-state option pricing model, is mathematically simple. Okay, so this is the simplest model we can use to find the option price. It is based on assumption of no arbitrage. Okay, so in reality they might have we have arbitrage, but we assume no arbitrage. Okay, so that's assumption for binomial model. Assumptions. So specifically assumptions, we have a lot of assumptions. So for example, there are 2 only two, okay? So this is a very strong assumption. Only two possible price for the underlying assets on the next day, okay? The underlying price will either go up or go down. So if increased by effect of U means up, so up percent, which is we call it uptick, or decrease by effect, we call it D percent, D means decrease. That's assumption one. Assumption two, the uncertainty is that we do not know which of the two price will be realized, but we know either one or two, either up or down, okay? And no dividends, okay, no dividends. One period interest rate R is constant over the life of the option, okay? So interest rate is it's constant. Markets are perfect. Markets are perfect, which is no commission fee, no bid-ask spread, no tax, no price pressure. Okay, so that's against the reality, right, situation. But because we talk about theory, model, right? Okay. The stock pricing process. So first, the stock pricing process. Like the assumption we talked about in the previous slides, only two price in the next day, right? So we have a day T and a day zero. We have a day T, which is in the future, expiration day, and the day zero, which is today, okay? So S0 means today, okay? The stock price today. And the TU means the stock price at the expiration date up. Okay, so that's stock price. And the TD, which is decrease, the price decrease at the expiration day. Okay, so that's talk about this is the binomial tree for stock, only for stock. Okay, binomial tree for stock. Binomial tree. Binomial tree for stock. And the binomial tree for option. Okay, so here the binomial tree for option, the time 0 and the time t, right? Again, we have a two time t and time 0. Time 0, the option price, we use F0. F0 could be call price, could be put price, right? Either call or put. So we use F to represent, which is general term, okay, for call and put. And the expiration date, the option price, or say option value, would be determined by the stock price and the strike price. Okay, and it depends on different option, different type of option. For example, if it's call, we would calculate the payoff. Here is a payoff, right? The payoff is maximum value between 0 and the stock price at the expiration date when stock price go up, and subject the strike price. Okay, when stock price go up, here is positive, right? If stock price going down, in this case, they might negative, right? So if it's negative, 0 and negative, we're gonna take 0, right? So that's for call. And for put, the formula is just the opposite. We just change the position for K and ST, right? K minus ST for put. So we learned this from chapter 10 already, right? So this is for put. That's for put. Once you understand the binomial tree for stock and option separately, we're gonna use that, okay, in our model. Application of no arbitrage argument. So this is approach 1. We're going to talk about the two approach. This is approach 1. Okay, this is method 1. No arbitrage argument. So what is no arbitrage argument? The application of no arbitrage argument basically say the value of option today is estimated through a riskless investment portfolio. So we first need to create a riskless investment portfolio, okay? And find out the expected payoff, okay? So basically for option, we have two time t and time 0 and time t. So we are looking for F0. So that's basically our question. So as long as we know a payoff, we can say this is FT. If you can estimate FT, then you just need to discount FT to F0, right? Discount, do a continuous discount, we can find F0. So our procedure, which is the first, you need to find out what is FT, okay? To apply no arbitrage argument to the pricing of a derivative, we first calculate the expected payoff of the portfolio, assuming the expected portfolio are the same when the price go up or down. So rather than we just consider just option, we consider both, okay, stock and option. Stock and option we consider is a portfolio, okay? So in the portfolio, we have a stock. We have a number of shares of the stock. We're gonna use the order, so we're gonna talk about that. So include the stock and the option. Okay, so in the portfolio, we have two types of security. So the value of the portfolio today is equal to the present value of the expected payoff, and then solve the equation to find the value of the option today. Okay, so big picture, which is we need to find the payoff of the portfolio in at the expiration date, and then we just discount back to time 0 to find the answer. Okay, so let's see how we're gonna use that. So we have example 1. A stock price is currently 20. So we can set up the binomial tree for stock first. Stock price, that's 20. Okay, so that's time 0. And then time t. It is known that at the end of 3 months, okay, so the t is what? 3/12, right? That's the time to maturity. So that's t. It will be either 22. So when stock price go up, TU, that's 22. When stock price going down, STD, that's 18. Okay, so this is binomial tree for stock. The risk-free interest rate is 12%, and with continuous compounding. Okay, so when you do compounding or discounting, you need to use continuous compounding. Okay, what is the value of the 3 months European call option with the strike price? Okay, so next we're gonna set up the binomial tree for option. So for option price today, that's we are looking for, right? That's basically the question. What is the value, which is what is the price? Value, price, the same thing, right? Like when we talk about stock value, stock price, basically same thing. So we are looking for the time 0, what is the option price? We don't know, right? But we know we can find the FT when stock price go up. So this is the call, right? So this is call. So for the payoff, we need to calculate by maximum value between 0 and ST up minus K, right? This is for up, and for down would be the same thing, right? D, but the maximum value between 0 and ST D minus K. So ST stock price go up or go down, that depend on what? Depend on the stock price binomial tree, right? So we can just plug that into the payoff for option. Stock price going up 22. Strike price, what is the strike price? 21. Can you tell me what is the option value at the expiration day when stock price going up? Can you tell me what the value? Anybody can figure it out. 22 minus 21. Can you, everybody hear me? I just want to make sure. Yeah. What's the answer?
1.
Yeah, that's correct. Okay, 1. So that's very critical part. Okay, critical step. You need to figure out what's the payoff for option when stock price going up at the expiration day. Okay, and the other case when stock price going down, that's 18. And the minus the strike price is 21. Can you tell me what's the payoff for option when stock price going down?
Is it 0?
Yeah, that's correct. Because 18 minus 21, that's negative value, right? That's negative value. So we take maximum value, which is 0. That's correct. Good. Okay. So that's very important part. You need to figure out the separately for stock and for option. Okay. Then we're going to combine at the portfolio. So first step, figure out the binomial tree for so that's the step 1. Okay, step 1, set up a one-step binomial model. And for call option value, that's the formula. And for stock price, that's 20. For option price, that's we are looking for, right? And when stock price going up, we have a stock price 22. Option value is 1. So we figured it out already, right, in the previous slides. And the stock price going down, that's 18, and option value is 0. So we did in the previous slides, right? So that's the first step. Set up one-step binomial model for stock and option. Okay. You can combine like a list like this, or you just do separately for stock and option, like in the previous slides. Okay, that's the first step. We're going to have 3 steps. And the next step, very important, which is we're going to combine stock and option. So it's kind of strategy. So the portfolio, so what are we going to do? Step 2. Step 2, we're going to set up a riskless portfolio. Okay, riskless portfolio. And find the number of shares, right? Because in the portfolio, we're going to have a stock and have an option. So how many shares we should buy? We don't know. So we assume a portfolio. So this is very important. We assume a portfolio that is long delta share. Delta, which is X. We don't know what that. We use the add delta, okay? So delta, you can use different symbol, but the delta represents, we don't know, unknown and shares. We're going to calculate that. We're going to figure out how many shares. So the strategy for the portfolio basically is the long shares, okay, long stock and short a call option. Okay, we're gonna long shares and short call option. Okay, the delta is the number of shares that need to hurt one call. If you long one call, you can hurt your risk by selling shares, right? If you long a call, you can hurt your risk by selling the other shares. So if you because you short a call, so in the future you're gonna sell shares and you buy share today, so you're gonna sell shares in the future. Okay, so that's why we have to do long shares and short a call. Okay, so which is you can do the other way, long call and sell shares, which is the other way. But no matter which way, you should be able to get the same answer. Okay, but they should be one long and one short. Okay, so if you take long shares and short option, then today option value, today's value of the portfolio would be 20. 20 is per share, right? 20 times delta, because the other shares. So 20 times delta minus F, minus Y, because you take short position, right? So make sure you understand why it's minus. You can put a minus F0, which is option price today. You just short one call, right? 1. So basically F times 1, right? Okay, so that's the value of portfolio today. And the value of the portfolio at the expiration day, same thing. We do stock price 22 times number of shares and minus 1, because this is the value of the option at the expiration day, right? And we have a one option, so 1 times 1 equal 1. If it's going down, and 18 times delta is number of shares, we don't know what is that, right? And plus 0 is 0, right? So This is very important step. You need to figure it out for portfolio. For the portfolio, what would be the value of the portfolio today and the value of the portfolio at the expiration day? Okay, that's the step one. And since we assume no arbitrage, that means what? The value expiration day, these two values should be equal. So no matter if stock price go up, going down, you get the same value. Okay, so that's called no arbitrage. If it's not equal, then you're gonna have a profit, right? You're gonna have an arbitrage. So, but here is no arbitrage assumption. So which means the value of the portfolio at the expiration day when stock price go up or down should equal. So we can set up the equation 22 delta minus 1 equal 18 delta. So starting from this equation, we can solve the delta, okay? We can solve delta. How? We can move 18 delta to the left-hand side, 1 move to the right-hand side. So 22 delta minus 18 delta equal 1, okay? So 22 delta minus 18 delta, that's what? 4 delta, right? Okay, equal 1. So delta equal 1/4. So that's 0.25 shares. Okay. You might say why the shares is not 1 share. In theory, we allow the shares can be percent, can be decimal. So so the portfolio include what? You should buy 0.25 shares of the stock and short a call option, right? So that's the portfolio. That's the portfolio. We figured out the delta. Okay, so this is a very important steps. Okay, this is very important steps. Once you get the delta equal 0.25, we can plug this number to the value of the portfolio when stock price go up and going down. So 22 times 0.25 minus 1. Can you tell me what's the number? What's the value of the portfolio?
4.5.
4.5, yeah, that's correct. And 18 times 0.25 equal what?
4.5.
That's correct, good. So you see, either up or down or 4.5, right? So now we can have a portfolio value in 2 time. The time t, which is expected payoff, we know that's 4.5, right, for the whole portfolio. And what is the value of the portfolio today? 20 times 0.25 minus F0. So 20 times 0.25 equal what?
5.
Yeah, that's 5. Okay, so for stock, we know the value, but we don't know F0. Okay, that's fine. So basically the timeline, the time value money question right now we get the time value money question, which is we want to discount this 4.5 back to time 0 and the setup equal. Okay, so that's basically step 3. Okay, step 3. Find the option price and the value today through the value of the portfolio today equal the present value of risk-free portfolio in 3 months. We know this is the 3 months, right? And the option value at the expiration day is 4.5, and today's value is 5 minus F0. So to set up the equation, we can first left-hand side is the value today. And the right-hand side, we do calculate the present value of 4.5. So to continuous discount, we do exponential negative interest rate is 12%, 0.12, and the times 3 months, 3/12. Okay, so we set up the equation. Left-hand side is the value of the portfolio at time 0. Right-hand side is the present value of expected payoff of the portfolio at the expiration day, right? We calculate the present value. So first, calculate the present value of the portfolio expected payoff. Equal what? I hope you use your calculator to do the work, okay, by yourself. So this part, you should get the 4.367, right? And then 5 minus F0. So to do this calculation, we can move F0 to the right-hand side. So left-hand side is 5 minus 4.367 equal F, the option price, the call price. So call price equal 5 minus 4.367. So that's 0.633. Okay, so 0.633. So finally, we find the option price, right, based on the binomial tree model. So basically 3 steps, okay, 3 steps. First step, set up a binomial tree model. Step 2, create the riskless portfolio, and then figure out the number of shares you should purchase. And then last step, find the option value price today. Okay, any question? Can you just take a look? Any question? Any question?
No questions.
Okay, good. So let's see one more example for put. So in example 1, we look at the call, right? Now let's look at the put example. So step 1, we're gonna set up one state binomial model. So I would like you tell me, for example, stock price going up, stock price going down. Can you tell me by reading the question? Tell me what's the binomial tree for stock and option. I'm gonna ask the student. So you figure it out. I'll give you 2 minutes. You can write down on your notes. I'm gonna ask a student to tell me the answer. Let me see who. Destiny, are you there?
Yes, Professor, I'm here.
Could you help me to figure out what the stock price binomial tree, stock binomial tree? For example, what the stock price today?
Yes, give me a second.
Yeah, take your time. What's the stock price today?
The stock price today is 50.
Mm-hmm. And the stock price going up?
It'll be 55,
Mm-hmm. When stock price going down?
45.
Yes. Okay, so that's basically the binomial tree for stock. And then we're gonna figure out the binomial tree for option. Okay, so option price today, we don't know. That's our question. We can figure out is at the expiration day, what would be the option value. So since this is put, our formula to calculate put would be maximum value between 0 and K minus ST, right? So you don't need to memorize the formula. It should be on the formula sheet, but you need to know what is that, right? So we would do the same thing for when stock price going down, but a different the stock price, right? So stock price K, the strike price is 50, right? Strike price is 50. When stock price going up, it's 55. So 50 minus 55 and 0, we take maximum value. Tell me what's the option value today? When stock price go up.
Is it 5?
No.
It's 0.
Yeah, this is 0, right? Because 50 minus 55 less than 0, that's negative value. So we cannot take negative value, we take 0. That's correct. And how about the stock price going down? K is 50. And the stock price when stock price going down is 45. So equal what?
5.
Yeah, that's correct. So we're gonna take a 5, which is maximum value between 0 and 5. Yes, good. So this is basically step 1. We figured out the binomial tree for stock and the option. Okay, and option. That's first step. So you can combine or you can separate, which is the setup for stock price, for stock and option. Stock price 50, go up 55, go down 45. When option value, stock price go up 0, going down 5. Okay, so that's first step. You need to figure out what's the binomial model for different security. And then we're going to set up a riskless portfolio, okay? Riskless portfolio. When for the call option case, we basically long the shares and short a call, right? So what would be the put option? So for put option, step 2, we set up a riskless portfolio. Same thing, find out number of shares. For the put option, we do short shares and long a put. Again, you can do long share and short put, same thing. So you should get the same answer. But in this way, it's more traditional way. Okay, short direct shares. Okay, and the long one put option. Since you know the structure of the portfolio security, you can calculate the value for the portfolio at time 0 and the time which expiration day. So you short direct share, so negative, right? So here's negative. Negative means you short direct share. So 50 times direct plus F plus you take long position on the put, right? So that's the value of the portfolio today. And the expiration day, which is 6 months, negative 55 times delta, that's the value for shorting delta share, right? And when stock price going down, because the option value 0, so we can skip that. And when stock price going down, negative, which is short delta shares for stock price 45, and the plus 5 is for one option, right? 5 times 1, which is 1. Once we set up this portfolio, and we can use the assumption which is no arbitrage. Since no arbitrage, the value at the expiration day should be equal. Okay, so that two equal, we can set up the equation, solve the problem. So negative 52 delta plus equal negative 45 delta plus 5. So to solve this equation, we can move negative 55 delta to the right hand side. So right hand side basically become 55 delta minus 45 delta, right? And then we move 5 to the left hand side, which is negative 5. So delta equal 55 minus 45, that's 10 delta, right? 10 delta equal negative 5. Negative, that's fine. Negative just means you take short position, okay? So 5 over 10, 5 over 10 equal what? Negative 0.5, right? So you might say delta, why delta is negative? Negative just means short. So delta equal negative 0.5 shares. Okay, then we can plug negative 0.5 to the value of the portfolio at the expiration day. So negative 55 times negative 0.5 equal what? Which is the negative, which is the positive, right? So positive 55 times 0.5, which is 55 over 2, so 27.5, right? And the same thing we calculate when stock price going down. So negative 45 times negative 0.5 and the plus 5. What is the value? What is the value?
2750.
Yeah, that's the same number, right? Yes, that's correct. So we basically set up we create the portfolio. It's riskless portfolio, and the portfolio will have the same amount of value which is expected to pay off 27.5, no matter stock price go up or going down. And today's value, so we're gonna find out we're gonna plug delta equal negative 0.5 to the value of the portfolio today. So negative 50 times negative 0.5 is what? Is that 25? 25 plus
Yes.
F0, right? F, you can put F or F0. F0 means the value today. Okay, so step 3 would be what? step 3, we're gonna set up the equation. Left-hand side is the value of the portfolio at the time 0. And the right-hand side is the present value of the expected payoff. So to calculate the present value, the payoff is 27.5. And we do continuous discounting, make sure negative is about the discounting, okay? Interest rate, what's interest rate? Interest rate 10%, okay? Interest rate 10%, so negative 0.1 times 6 months, right? 6 over 12. Can you calculate the value, the present value of the expected payoff, which is the right-hand side of the equation? Please calculate the right-hand side.
I got negative 2616.
Should not be negative, right? Why negative? We do not
Or
have
positive 2616.
26.16, right? Yeah,
Yes.
that's correct. That's correct. 26.16. Okay. So to solve this equation, we got a 25 left-hand side plus F0, and the right-hand side is 26.16. So the option price or option value should be equal what?
It's negative 25, right?
Negative 25? No, negative, no negative, because you see here, positive, negative, negative, positive, right? Because delta is negative. So here's negative, here's negative, would be positive. Okay? 25 is not negative, it's positive. You see that?
Is it 1.16?
Yes, that's correct. 1.16, that's the option price. Good, yeah, this is what we are looking for. 1.16, okay? This is $1.16. So please try to understand the big picture, okay? We basically have 3 steps. Step 1, set up a binomial model for stock and option. Step 2, we're gonna create the portfolio, which is the riskless portfolio, no arbitrage, and figure out what's the number of shares they're gonna take in the portfolio. And finally, we're gonna use the expected payoff and then to find out the option price. So make sure, okay, make sure why this is 25, okay? I think this is the place like a lot of students make mistake. So why is positive? Because we have negative, negative is positive, okay? So delta could be positive, could be negative, okay? Negative just means cash, that's the short position. So step 3, here is the answer, 1.16. Okay, 1.16. So this table basically shows the current, the value of the option must be $1.16. To summarize what we covered today, we basically talk about the first approach, which is no arbitrage argument. Use this approach, we can figure out the option price by creating a riskless portfolio, right? So next class, we're going to talk about the other approach, which is the risk neutral valuation. Okay, so that's a different approach, but we can get the same answer. Okay, so that's all for today. Any question? So we're gonna talk about the other approach on Wednesday. Question?
No questions, Professor.
Okay, good. So for this week, you need to do the assignment. Also, I would suggest you start to work on your case. Okay, do not leave the case report to the final, to the week before the final exam. That would be very busy. Okay, so do your work as soon as you can and as long as you have time. Okay. And make sure you sign up a group, okay, on my course. If you have a question or if you have a problem, just let me know, okay?
Thank you very much. Have a great day.
Yeah, you too. Okay, have a good
you.
day. Bye.
Bye, thank you.
Bye bye. Have a nice day.